Hey everybody, it's Hailey, and today we're going to talk about enzymes, so enjoy. First of all, what are enzymes? Well, an enzyme is simply a protein that speeds up reactions and decreases the amount of energy needed for that reaction by acting as a catalyst. The without being consumed by the reaction part simply means that an enzyme can be reused more than one time, so it's not just like a one-time thing. Also, the active site is the specific portion of the enzyme that the substrate binds to. So what is enzyme substrate specificity? Well, the specificity is simply the fact that one particular type of substrate can only bond with one particular type of enzyme. For example, sucrose can only bind with sucrase. Also, this idea is known as the lock and key model, as shown on your right, and the lock and key model simply illustrates that substrates always bind with their correct enzyme because the active site of that enzyme is perfectly molded to fit the particular substrate. It just comes like that. It looks like a lock and a key. Another model is also the induced fit model, which is a similar idea, but instead of the active site being already molded for the substrate that it's supposed to be molded to, when that substrate comes in, it kind of molds around the substrate. So what are some things that can affect the efficiency of an enzyme? Well, one big factor is temperature. Optimal enzymatic activity occurs under a limited range of temperatures. In the human body, that temperature is 98.6 degrees Fahrenheit. And so if the body becomes too hot, like a fever, or too cold, then the enzymes begin to break down and lose their efficiency, which I will talk about that process a little later on. Another big thing is the pH levels. Enzymes in the human body typically work best in neutral pH levels, which is like 7, although there are some enzymes like gastric enzymes in the stomach that work more efficiently in acidic solutions because obviously they're in gastric acids. Substrate concentration is a huge factor in whether an enzyme is active or not. Because enzymes are substrate specific, the amount of substrates that are available to catalyze don't really affect the efficiency per se, but they determine whether the enzyme's active or idle. So if there's a lot of substrates to be processed, then the enzyme will catalyze the reactions until there aren't any more substrates. But if there really aren't that many substrates, then the enzyme's idle. So what's denaturation? Denaturation is simply when a protein unravels, which means it loses its natural shape and becomes biologically inactive. I mentioned it earlier, and it can be caused by extreme high or low temperatures. Like if your body has a really high fever, then that's part of why your body processes kind of start to shut down, or extreme conditions of pH. So one interesting thing is discussing what lactase does in lactose-free milk. Lactase is the enzyme that breaks down the disaccharide lactose into its monomer units of glucose and galactose. Lactase is added to milk and then gently heated to catalyze all of the lactose into glucose and galactose. This eventually breaks down all of the lactose in the milk so that a lactose intolerant person can drink it without having a negative reaction, because instead of having lactose in the milk, you have just glucose and galactose. So now it's quiz time. First question. Enzymes are A. Substrates that act as catalysts, B. Proteins that act as catalysts, C. Substrates that act as chemical messengers, or D. Proteins that act as chemical messengers. And the answer is B. Proteins that act as catalysts. Second, which of these does not have an effect on enzyme activity? A. pH level, B. Temperature, C. Cell size, or D. Amount of substrate. C. Cell size. Third question. Which of these can cause an enzyme to denature? A. Extreme presence of nitrogen, B. Extremely neutral pH, C. Extreme osmosis, or D. Extreme hot or cold temperatures. And that one's obviously D. Extreme hot or cold temperatures. 4. What are the two monomer products after lactose is broken down? A. Lactase and fructose, B. Glucose and galactose, C. Galactose and fructose, or D. Glucose and cellulose. B. Okay, thanks for listening.